In 6-1, we basically said, if we have a parallelogram, and we know we have a parallelogram, what other things do we know? We said opposite angles will be congruent, opposite sides will be congruent, diagonals bisect each other, consecutive angles are supplementary. We said all of that stuff yesterday. And today we're going to say, what if I just give you a quadrilateral and I give you certain characteristics? Could you tell then if it has to be a parallelogram? Is really what we're going to look at today. And you notice you're not quite as lucky as yesterday that you actually have to fill stuff in today. So there are only 5 of them, and I will again highlight the one that most people mess up. What was the one that most people forget about yesterday? It was the 5th one, and what does it say? Yeah, diagonals bisect each other. Or was that the 4th one? I think it was the 4th one, wasn't it? Diagonals bisect each other. That was the biggest one yesterday that people will forget about. And again, I'll try and highlight that for you. So let's say you just have some quadrilateral sitting there, and it has this particular quality, that both pair of opposite sides are congruent. So I have a quadrilateral sitting there, and we are basically told that both pair of opposite sides are congruent. So in other words, that one's congruent to that one, that one's congruent to that one. That's what we know. Do you believe that is enough information? Again, we always try to find out what's the minimum I can have to know for sure. We do that with side angle, side angle, side angle. And again, mathematicians going for the minimum. Kind of lazy, right? Let's get down to the bare bones here. If I have that information right there, am I guaranteed that that quadrilateral has to be a parallelogram? Yeah, it does. Okay. If both pair, not just one pair, both pair of opposite sides congruent, you're good. Okay. In other words, there's no way that you could take that information and not make a parallelogram. Okay. Kind of again like that spaghetti noodle idea. There's no way you could do that. So the second one should be around there somewhere. Both pair of opposite angles congruent. Again, so you got some quadrilateral sitting there. So this one we said, yes, this one's good. We know it's a parallelogram, right? So how about this one over here? Well, let's just kind of throw some information up here, maybe something like that. Well, it's a little off, but you get the idea. That one's congruent to that. That one's congruent to that. That's what this is saying, right? Both pair, right? That pair and that pair are congruent. Do you believe that to be enough information to guarantee that that quadrilateral is a parallelogram? Yeah. Do I need one and 2, or can I just have number 2? This number 2 is enough. Yeah, if you've got that, you're good. You know that this quadrilateral, and notice which word I keep saying, quadrilateral. So if you have a pentagon and this happens, or a hexagon and this happens, there's no guarantees that it's obviously not going to be a parallelogram, right? Because you have to start with at least a quadrilateral. It has to have, and quadrilateral means what? A 4-sided polygon, and polygon means what? The closed figure. You see how we just review all this stuff. So that's good. So how about this one? Ooh, diagonals that bisect each other. Now, in all of these so far, is it possible we have more than a parallelogram? Like perhaps, is it possible we have a rectangle or a rhombus or a square? Are all those still possible? Yes, but they're not guaranteed. Parallelogram is guaranteed here. So diagonals bisect each other. All right, we'll do that one over here. So maybe we'll go something like this. So we'll do the color coding again like we kind of did yesterday. I'll try and get out of your way a little bit. So if I gave you, again, I gave you a quadrilateral in black this time, and I gave you the diagonals bisecting each other. If I give you that information, again, maybe I'll just give you the red as 5 and 5 or something like that. It doesn't have to be congruent marks. If I give you that, are we guaranteed it to be a parallelogram? Yes. How about, say, a rhombus? Are we guaranteed it's a rhombus? Well, not necessarily. Now, if I start throwing some of these together, then we might start getting to a rhombus, right? If I like put several of these together, then we might. But not yet. We do know parallelogram. So you're starting to see what I mean. If you kind of understood things yesterday, this is really the same stuff, just doing it opposite. We don't know it's a parallelogram yet, and we're trying to prove that. So that was the key one yesterday. Today, I would say this is the key one. The one you might want to highlight or star or whatever it is that you do to remind yourself, oh, Mr. Boca said this is one that people forget. And so I might want to try and remember this one. And it's kind of weird how it has been worded. One pair of opposite sides parallel and congruent. how do I draw that to show you that that's what we have? How would I go about that here? Any ideas? How would you draw one pair of opposite sides that are parallel and congruent? It's got to be both. Yeah. So which ones do you want to do? The top and bottom? So I should make this parallel to that one and also congruent to that one. Is that what this one's saying? This is exactly what this one is saying. Does it have to be top and bottom? No, it could be left and right, right? But is that pair of opposite sides parallel and congruent at the same time? And that's all you need to know. That'll work. Because just imagine, let's say I took this one and I moved it over a little bit, and then I made that congruent one down there. Is that still guaranteed to make a parallelogram? If I know they have to be the same and parallel, I'm stuck. Okay, it has to work. So again, highlight it because it is one that people forget. So this one, yep, parallelogram, has to be. And there is a fifth one. Well, which one from yesterday have we not covered yet? Let's see if you can think backwards a little bit. He knows if he looks. It's kind of the obvious one. Both pair of opposites parallel? Yeah. Yeah, well, isn't that kind of, what is that for parallelogram? That's the definition, isn't it? A quadrilateral that has both pair of opposite sides parallel? And I think that's so obvious we might not even have to state that, because if you see one, you know that's a parallelogram, right? Because that's what I told you to always look for. Make sure it has that information. That. We're good. Now there is one, the supplementary one is one that we haven't talked about yet, and we'll get to that. Okay, at a later time. So which one's the one most people forget? 4. And you might notice that I did try and actually make those the same number on both days. Right, the ones that people forget. Okay. Once again, not much is random of what I do. Well, let's see if you can use that. Determine if the quadrilateral has to be a parallelogram, based only on the information given. I think I actually gave you the same information today, didn't I? It's not like I did a little different. So we have to justify our answer. So letter A, I think we agree that is a quadrilateral with one of the diagonals drawn. With the information given, does that have to be? Are we guaranteed, without a doubt, that it's a parallelogram? How do you know? Number 4, right? Isn't it? The most common forgotten. Whoop. Is it right there? Come back. Right there. One pair of outside parallel and congruent. That's the one thing I don't like. Once I fade it in, I wish it would stay until I reopen it. I'll have to call Smartboard and tell them that. I could freeze this, but it doesn't. Then I can't go to the next page. Yeah, so I won't freeze. Yeah. I could always edit it once it gets here, but it's a pain. It's this one, right? That number 4. So yes, you are correct. And your reason would be, and you could just say for our purposes, we'll say number 4. Because you could write that whole sentence out, but who wants to do that? How about letter B? I hear a yes and I hear a no. Okay, I've been told yes and no. Someone just told me that this doesn't fit any of the 5. What do you think? How about over here? All the answers were coming from the other side of the room. Yes or no for B? And why do you say no? The markings are true, yeah. Okay. The statement was it could be a rhombus, a square, or a rectangle, but those are all types of parallelograms. So it would still be a parallelogram. Okay. Yes. There we go. Somebody finally got there. So the answer is no. The true reason is, if you were to think about it, does it meet any of the 5 we just did on the other page? Not completely, right? If the 6s were on, say, the top and bottom with the parallel, then we'd be good. But the key is to actually know why. By the way I drew it, Is it a parallelogram? Okay, by the way I drew it, the computer did it. So did the computer make a parallelogram when it did it? It did, but based on the information given, we don't know for sure because it could be this. Do you agree that those two are still parallel, top and bottom? Could that be 6 and that be 6? Is that a parallelogram? No. That's the true reason this one does not work, because you could draw something else. It's not guaranteed. And the ones I gave you are the ones that are guaranteed. All right? This particular one also deals with the supplementary issue. Okay? Those could be supplementary, and I wouldn't necessarily get a parallelogram. All right? So this is no. So that's why that one of the consecutive angles being supplementary is not thrown in here to guarantee a parallelogram, because it could be a trapezoid. To justify this one, you would say it doesn't meet any of the 5. Yeah. Or you could say it could be a trapezoid and draw it. Draw a counterexample is always a good justification. Okay? Draw what makes it not work. Determine the value of x and y that ensures that this quadrilateral, I think we can agree it's quadrilateral, has to be a parallelogram. Well, are we going to use the fact that the top and bottom, left and right, have to be parallel? Probably not, because we're not talking about slope, but we are talking about length. And so what do we know about length? In R4, which one talks about, say, the length of the sides? Yeah, both pair of opposite sides has to be congruent. That's number 1. So in other words, the top and the bottom better be congruent for this to work. So 2y has to equal y plus 3, and the left and the right better also be congruent. And so why don't you go ahead right now and solve for both x and y on your own. Well, let's see how you did. In red, we are going to try and solve for y. People have struggled with this particular type of algebra before because they tell me this. They subtract the y's, and they say the only thing left is 2. All right? Of course, that is not correct. Because you had 2 y's, you only subtract one of the y's, you still have a y. These two do cancel. It equals 3. You probably should check, if I substitute 3 back in, what are the lengths of those two sides? 6 and 6, so we're good. And in black over here, we will solve for this one. Again, probably subtract 4x is the quickest way. It's not the only way, but probably works fairly quick. Equals 8, divide by 2. X is 4, so you probably should check that. Both sides are 24, so is this drawn to scale? Probably not. But it doesn't have to be. We are now guaranteed that that picture will be a parallelogram because of number 1. Both pair of opposite sides are going to be congruent. On this one, determine the value of x and y. Well, this one's a little trickier. How are we going to go about this? Okay, yes. Okay.
So you instead 2x plus 8 is equal to 120. Solve for that. And then your
Okay. Okay, pretty close. That's good. Basically, let's start with the opposite angles being congruent. That was one of our justifications, correct? That the both pair of opposite angles are congruent. That's basically number 2. And so we can solve this. And so let's find out what this x value is. So 2x equals 112, right? Divide by 2. X is relatively large. Is that okay? Yeah, it doesn't matter how big x is, as long as when you substitute x back in, it makes everything true. It depends on what algebra you have there. And if I put 56 back in, yep, we do get 120. Now, seeing it is a quadrilateral, I like what was said. We do know that the total does have to be 360, right? You could look at it that way. And so we know 120's been used up, 120's been used up there, right? And so how much is really left over is 120, and so for each one would be then 60, right? Does that make sense? So 5y would need to equal 60, right? And so you divide by 5, y is, what is it? 12. Yes. Right, but it's saying determine the value of x and y that ensures that this quadrilateral will have to be a parallelogram. So I'm finding the only x and y values that'll make that true. For example, if x is something else, this will not equal 120. And so then it would be guaranteed to not be a parallelogram because it doesn't meet number 2 on the criteria that we had for today. If you can't ensure it, then you'd say that you can. But we found an x value and a y value that does ensure it because it makes number 2 actually happen on your notes. But yeah, it is very possible I could be tricky and give you one that you really can't. And then say, what are you going to do? I believe you have one more thing than I do, correct? 1 minus y? How are we going to go about this one? And which one is it actually working with? Well, obviously we're going to try and do what with the angles? Make them congruent. Why? Not necessarily. If I make these angles congruent, that doesn't say that it's a parallelogram. That says that those angles are congruent. What's that? They are alternate interior angles. So proving these two congruent actually does what? Proves that these two are parallel. That's what it actually does. Does that help me then? Again, you don't just set things equal just to set things equal. Have a reason for it. That does help me because then if I can also make those sides congruent, those sides are both parallel and congruent at the same time, which is number 4. Okay? And so let's see if we can do that. Let's go ahead, set 2x plus 3 equal to 3x minus 7, and see what you get. Because yes, we do want to set them equal, but you have to know why. Again, this is where some people's algebra gets a little goofy. You can work in either direction. I like to do it this way. I like to move the smaller variable. You don't have to. 3x minus 2x is just x minus 7 plus 7. X is 10. Again, you should check. If you put 10 back in, do those angles actually end up being congruent? They're both what? 23. And what does that really tell us again? That the top and bottom are parallel. Okay. So we've got that. If x equals 10, we got the top and bottom being parallel, but we also have to find what y value will make the top and bottom congruent. So I've got this. I got to set that. Well then, this is interesting. Well, let's put things together here and find out what happens. So subtract 1 from that side, subtract 1 from that side. Y equals, it is y, 1 minus y on your paper, right? Okay. Y equals negative y. Well, isn't that great? So you want to add y over? Okay, add y over. So 2y equals 0. Divide by 2, y is 0. Now, what are we trying to do? We're trying to make the top and bottom congruent at this point. If I put 0 in, are they actually congruent? They're both what? 1. Oh. Is it okay that your answer is 0? Yeah, because is 0 the length of the side? No, 0 is the y value I have to put in to make the two sides the same or congruent. And so I have them being parallel and congruent, so by number 4, we are guaranteed, without a doubt, that this quadrilateral turns into a parallelogram. So the whole key of today is, yeah, we don't have the parallel marks on there like we had yesterday. We have to find out what's going to give us a parallelogram. And can we or can we not? It's very possible we can't. All right, so now we got x and y. Once again, we have to make sure that it's a parallelogram. I think it's fairly obvious which one we're going to try and use this time. We have all information about diagonals. Yeah, so diagonals bisecting each other, which is number 3. It was number 4 yesterday. It's number 3 today. So 3y has to equal 3y. And 2x has to equal 2x. Well, this is interesting. Divide by 3. So y has to equal y. Well, I sure hope so. Y better be y. So how do you do this then? Okay, well, let's subtract y. And I get 0 equals 0. Oh, so you're telling me I can put anything in for y that I want, and this will work? So how do you say that truly? What's the quickest one? All real numbers. It's a very good way to say that. So y, the only reason this works is because it came up to something that was actually true. 0 does equal 0. Y better equal y. Okay, so that's why that works. So all real numbers will actually work. And so in other words, all real numbers will get me towards getting a parallelogram. And I hope you see that the exact same thing is going to happen over here. No matter what I put in for x, I'm going to put the same thing in for x over here, and isn't going to be the same thing? Okay. So you do all the math, you get basically 0 equals 0 again. And so once again, x would equal all real numbers. Yes? What's that? Pi is a real number. You're thinking rational versus irrational. Yeah, any real number will work. Imaginary numbers we'll talk about a little bit later in Algebra 2. It's a whole different branch of mathematics. They do. It's one of those things that's almost a paradox. Imaginary numbers do exist. See how that's kind of a paradox there? And basically without them, a lot of mathematics would not happen. So what happens? Good question over here that they had, and I answered it. Another good question is, what if you do all this math, but you get down to something that's not true? For example, 0 equals 1. I hope you notice that that's not true. Exactly. You can't give me an x value or a y value that'll actually make this a parallelogram. It does not exist. Okay, because there's no way that both of them are going to end up the way they're supposed to. So yeah, at that point you say, yep, sorry, I'm glad you have a quadrilateral, but I can't make it a parallelogram. Okay, that's what the algebra tells you. Okay, so are there any questions other than the ones you've already asked?